This is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through unions and intersections. So we're really looking at unions and intersections of sets. So a set is just a collection of objects. We could talk about the set of prime numbers, the set of, all students who play soccer or whatever. So we want to have information about how many members there are, how many elements are in each set, and use them for probability calculation. So that's what we're going to do here. So we're going to start off with, an example involving sets and cards. So let's just take a normal deck of cards, and I'm going to let A be the event that I pick, say, an ace. And I will let B be the event that I pick a heart. So we want to display information about the number in each set, or in both sets, or in neither. So the two ways you would have already learned to do this are two-way tables and Venn diagrams. So they essentially provide the same information. The idea is they show you how many is in each set, and we use that for probability calculations. So let's start off with a Venn diagram. So you should have a box around it, and you have two circles representing the sets. So in this case, we have set A, which is ace, and set B, which is hearts, okay? So we'll just fill in the Venn diagram with numbers. There should be 4 numbers, one that goes there, there, and there. So this middle section you can see is in circle A and circle B. So this is what we call the intersection of A and B. So we write that little N there, which means intersection. You read that as A and B, both of them. So the number that goes there is the number that are in A and also B. So if I'm talking about cards and aces and hearts, so it turns out there is one. There is one card that is both an ace, so it's in the A circle, but also a heart. It's in the B circle. It's the ace of hearts. So the number I put in there is the number 1. Now, hopefully you know that in a deck, there are 13 of each suit. There are 13 hearts, there are 13 clubs, 13 diamonds, and 13 spades. So in the B circle, there should be 13 elements, 13 cards. I've already put 1 in there, which is the ace of hearts, so there'll be 12 more that go here. So this section here is B only. It's B but not A. Cards that are hearts but not aces. So there's 12 of those. There's the 2 of hearts, the 3 of hearts, the 4 of hearts, and so on. So that's why there's 12 there. So in each deck, there are 4 of each rank. So there's 4 kings, 4 tens, 4 aces. So I've already included the ace of hearts in the A circle, so I need 3 more. There are 3 aces that are not hearts. Of course, the ace of diamonds, ace of spades, and ace of clubs. So this number here, this section here is A only. Things that are in set A but not B. Now, outside the Venn diagram, these are things that are not in A and not in B. A way we can write this is not in A, intersection, not in B. It just means basically neither. So outside here, all the cards that are not an ace and are also not a heart. So there are 52 cards in a deck, as I mentioned. So you can see the numbers inside the Venn diagram, 3 plus 1 plus 12 equals 16. So there must be 36 outside because the numbers in this Venn diagram need to add to 52 because there are 52 cards. So we've gone through the intersection A and B, which is this one. So that's intersection. What about union? Well, union actually means A or B, and it's everything inside the circle. So all of the cards that are either a heart or an ace are included here. So this section here that's shaded in green, everything inside the circles is written as A union B. Read that as A or B. It's important that we note, however, that when we say A or B, we mean A or B or both. When I say a card is an ace or a heart, I really mean it's either an ace, it's either a heart or it's both. So I have to include in the union, in A or B, I have to include the case where it is both A and B. So A and B is part of A or B. It's included in that. So that's going to be very important moving forward, even in our next lesson when we look at the addition rule. So I said before that you could write the information as a Venn diagram or a two-way table. Well, I've just written it as a Venn diagram. A two-way table does the same job. So when you're drawing up your two-way table, it should end up being actually a 4x4 table. So what you do is you have two ways which correspond to the two sets. So we call our sets A, and A dash means not A, not in A. And then B and B dash, obviously B dash means not B. So unlike the Venn diagram, we have a row for the total, which we don't have in the Venn diagram. So we populate this with numbers. It turns out that the numbers that go in these four boxes are the exact same as the four numbers in the Venn diagram. So each of these boxes I've shaded yellow will correspond to one of the numbers in the Venn diagram. So this first box here, it's in this column, so it's in A, it's in this row, which means it's also in B. So this is the place where I put the number that are in A, but also in B. So we know from the Venn diagram that that's 1. There is one card that is an ace and also a heart. So what goes in the next box along here? So this is not A and B. B and not A means B only. So we can see from the Venn diagram that that number is 12. This down here is the opposite. This box represents ones that are in A but also not in B. A only. So that's 3. It comes from the Venn diagram, and you guessed it, 36 goes here. Not in A and also not in B. So we can just add the totals that might help us with our calculations. Of course, everything should add to 52. These two numbers and these two numbers should add to the same thing. They add to 52 in this case because there are 52 cards. So hopefully you can see Venn diagrams and two-way tables provide the exact same information. So we can use this to help us with probability calculations. So let's say I pick a card at random. So it has to be at random, otherwise we can't sort of figure out its probability. So let's say I pick a card at random. So what is the probability of this, which is A and B? So that's saying, what's the probability I pick a card that's an ace and also a heart? We see there are one of those out of 52 in total. So that's pretty simple. So what would be the probability of A union B? What's the probability of their union? So remember, that's saying what's the probability the card is an ace, is a heart, or is both? So to figure out how many are an ace or a heart or both, we need to add up 3 numbers. So remember I said the union is all of what's in the Venn diagram. So it's 3 plus 1 plus 12. 16. Same as in the two-way table. 3 and 1. These are all cards here. These are all aces. And this card here is a heart. So 1 plus 12 plus 3 is 16. Because when we say 16 cards are either an ace or a heart, we're saying that there are 16 cards that are either a heart only, that have a heart symbol on them, have an ace symbol on them, or have both of those on them. And there are 16 in total. Of course, probability has to be a number between 0 and 1. So it'll be 16 over 52, which is 4 over 13. So that's how you figure out unions and intersections. They can be very, very helpful tools because sometimes we want to know the probability that 2 events both happen or that either of the events happen, and that's how we do it. So two-way tables and Venn diagrams are a very convenient way to organize information to allow for those probability calculations. All right, this has been the luckiest maths teacher in the world. Have a great day.